Hello, welcome to Pre-Technical Mathematics. This video lecture is on applications. It's from the supplement, chapter 13, section 5. This is probably going to be the hardest part of trigonometry, but it is the most important. So let me walk you through a couple of these word problems and let's see how they can be applied to trigonometry. Alright, let's see what we've got. The recommended safety angle of a ladder against a building is 78 degrees. Okay, I'm going to stop there. Now, I'm not an artist, so you have to be patient with me. And I've got a ladder here. And that is 78 degrees, right? Ladder against a building is 78 degrees. A 10-meter ladder will be used. Okay, stop there. How high up on the side of the building will the ladder safely reach? So I want to know this side. Alright, now we're going to use trigonometric functions in order to solve this. What do we have? We have the angle 78 degrees. What does this side refer to? That's the opposite side, right? And this side is again the hypotenuse. And what we've got here is a nice little right triangle. So opposite and hypotenuse, if you remember, is sine. So we'll take the sine of the 78 degrees equals the opposite. We'll just call it opposite for now. Now let's put in H-E-I-G-H-T. That's what it really is, isn't it? Over the hypotenuse, 10 meters. So if we do our math, we've got sine of 78 degrees times 10, and we should come out with that height being 9.78 meters. Alright, so take these word problems step by step. Draw a diagram. I am a very visual person, and I think even those people that are not visual, a little diagram will help. And it'll certainly explain it to me. Alright, let's go to the next one. Okay, a smokestack is 180 foot high. Alright, let me get my smokestack. That's my smoke, by the way. And this is 180 foot. Okay, we've got that. A guy wire must be fastened to the stack 20 foot from the top. Okay, so let's put my guy wire. And this distance is 20 foot. The guy wire makes an angle of 40 degrees with the ground. Okay, so the guy wire makes 40 degrees with the ground. Find the length of the guy wire. So this is what we want, the length of the guy wire. Alright, if we get a right triangle, what we've got is 40 degrees, and this length is 160. I didn't write that very well. Because it's 180 minus the 20 gives us 160 feet. Now this side is the opposite side, and again this side is our hypotenuse, and that's what we want to find. So opposite and hypotenuse, that's our sine function. So we'll take the sine of 40 degrees equals our 160 degrees feet divided by the length of the guide wire. Okay. That's our hypotenuse. Okay, so our math, the length equals 160 divided by the sine of 40. And we should get that equal to 249 feet. Okay, so not too bad. The only trick here was we had to subtract that 20 feet from the 180 because we really want this part of the triangle. All right? The picture helped us tremendously. Let's see what we've got next. A small plane takes off from an airport and begins to climb at a 10-degree angle. Okay. Let's see. That's my plane. It's a little jet. And he takes off from an airport at 10 degrees at 5,000 feet per minute. Okay, so this is 5,000 feet per minute. That's how fast we're traveling. After 3 minutes, so we'll put our 3 minutes because we're going to go 5,000 feet per minute for 3 minutes. How far along the ground will the plane have flown? So what we're asking for is the ground distance. Okay, first of all, we multiply this out and we're going to get 15,000 feet. Now what we want to find, this is the adjacent side of our angle. This is the hypotenuse. Our trig function that uses adjacent and hypotenuse is cosine. So we have cosine of 10 degrees equals we're going to call it ground over the 15,000 feet. Okay, our algebra. And that should come out to 14,772 feet. I'll just write in here one more time that that's the ground. Okay, let's take a a look at it here. The hypotenuse is 15,000 and it's only at 10 degrees. So this distance is going to be very small, but this distance is going to be very large. So 14,700 sounds right about there as compared to 15,000. So that way I know I've got the right answer. Okay, this is the last problem. Okay. Machinists often use a coordinate system to drill holes by placing the origin at the most convenient location. A bolt circle is the circle formed by completing an arc through the centers of the bolt holes in a piece of metal. Find the coordinates of the centers of 8 equally spaced quarter-inch holes on a bolt circle of radius 6 inches. Oh boy. Okay, let's take it. Here is my piece of metal. Now I've got 8 quarter-inch holes on a 6-inch, let's put my center here. There's 1 quarter-inch hole. There's 2. There's 3, 4, 5, 6, 7, and 8. Now what we know is that this distance is 6 inches because it's on a bolt circle radius of 6 inches. That's just like taking a circle around here through all the bolt holes. Okay, now we know that from this hole to this hole is 90 degrees. This one's right in the center, so we know that as 45 degrees. We'll label this hole as B. What we want, let's draw our triangle. And this is 6 inches. This is 45. And what we want to find is the y distance and the x distance. Okay, now let's see. Use a coordinate system to drill holes. They place the origin here. Then they want to come out in the x direction and go up in the y direction and bang, bring the drill press down and make the hole. It's very difficult for a machinist to start here and get his machine to go a 45 degrees on a 6-inch radius. They usually work with an x and a y coordinate. So that's why this is so important. So how do we find the x and y coordinate? We know that the sine of 45 degrees equals the opposite, which is y, divided by the hypotenuse, which is 6 inches. So the sine, let me just write this out, sine of 45 times 6 equals y. That should give us 4.24 inches equals y. And since it's a 45-degree angle, x and y are equal, so x also equals 4.24. Okay, let's see if we can find all the holes. Here's A. What are its coordinates? In the x direction, it is 6. In the y direction, it is 0. B. We found that one, 4.24 in the x and 4.24 in the y. Let's find C. C should be, let's see, 0 in the x and 6 in the y. How about D? D should be negative 4.24, right? We're going in the negative direction here. And the y is still positive 4.24. How about E? Here's E. X should be negative 6 and y should be 0. I think you're getting the hang of this by now. Here's F, G, and H. Can you do the rest? Try it. Okay, this is the end of our video lecture.